Welcome to this video on Flight Management Systems, or FMS. We will cover the architecture, operation, and maintenance of these crucial avionics systems. The FMS is an integrated system that combines area navigation and performance management to optimize flight operations. Its purpose is to reduce crew workload, improve navigation precision, and minimize operating costs. The FMS performs 4 core functions: navigation, flight planning, performance management, and guidance. These functions calculate position, create flight plans, compute optimum speeds, and provide steering commands to the autopilot and autothrottle. FMS architecture utilizes dual flight management computers, FMC 1 and 2, which crosstalk to compare data and ensure redundancy. The Multi-Control Display Unit, MCDU, is the primary pilot interface. The FMS receives critical inputs from various sources, including navigation sensors like GPS and IRS, air data computers for true airspeed and temperature, and engine data for fuel flow and thrust. System outputs guide and display the aircraft's path. These include the electronic flight instrument system, the autopilot, and the thrust management system, which drives the autothrottle. The computer memory architecture includes bubble memory for non-volatile navigation and performance data, CMOS RAM for active flight plans, and UV-PROM for the operational program software. The brains of the FMS are its databases. The navigation database contains airports and routes, updated every 28 days. The performance database holds detailed aerodynamic and engine thrust models. FMC configuration uses program pins, which are connector pins at the rear of the unit. These pins discreetly tell the software the specific engine type, weight units, and airline options for proper operation. The Control Display Unit, or CDU, is the primary hardware interface for the pilot. It features a display, line select keys for data selection, and a keypad for alphanumeric data entry. CDU display logic uses different character sizes and prompts to communicate information. Large characters indicate crew-entered data, while small characters are computed by the FMC. Box prompts show mandatory entries. Upon startup, the system performs a power-on self-test. The first page displayed is the ident page, which verifies the aircraft and engine type, as well as the validity dates of the navigation database. In the POS INET operation, the Inertial Reference System, IRS, aligns itself. This requires a starting latitude and longitude. The aircraft must remain stationary until the green ready nav light indicates alignment completion. Flight planning involves entering the origin and destination, structuring the route with airways and waypoints, and activating the plan by pressing exec. Pre-stored company routes can auto-populate the plan. The perf init page requires setting the cost index. A low-cost index prioritizes fuel economy, resulting in a slower speed, while a high-cost index prioritizes time, resulting in a faster speed. LNAV, or lateral navigation, steers the aircraft along the programmed ground track. VNAV, or vertical navigation, manages pitch and throttle to follow the optimized climb, cruise, and descent profile. The in-flight progress, or POG page, monitors flight status, providing the estimated time of arrival, computed fuel remaining at the destination, and real-time wind data. The FMS uses Kalman filtering to mix sensor data from GPS, DME, VOR, and IRS. This filtering creates a hierarchy where GPS has the highest priority and continuously corrects IRS drift. Maintenance procedures include built-in test equipment, BITE, to monitor the system and access maintenance pages. A data loader is used to update the navigation database. Input pages check sensor continuity. This complex integration of inputs, dual redundant computers, software, databases, and outputs makes the flight management system the true quote-quote brain of modern aviation.